This is referred to as the power rule. The power rule can be applied to any power function with the format y equal x raised to the power of n. And the derivative function is bring down the power as the coefficient x to the power of n minus 1. And this is the first rule of derivative, which you cannot use yet for your first test and the thinking task number 1, but you can use it to check your solutions quickly, okay? But you cannot just write the answer and say, yeah, according to the power rule, here's the answer, right? For the first unit, you need to show understanding of first principles. And usually on the final exam, you'll be given a first principles question. Now, we don't have a final exam, but we do have a culminating, and usually on the culminating, we'll have a question where we say you must solve using first principles, okay? But we're only gonna ask you once, like not 10 times. Unlike the first unit test, you may be asked to do more than once. Okay, now applying the power rule, which makes life so much easier. If I actually have to solve this by hand, x to the power of 10, that's gonna take a while, because expanding x plus h to the power of 10 is probably gonna take you half an hour if you're actually gonna do it by hand. Some of you say, oh, I know Pascal's triangle. That's good. It's probably slow down shorten a lot of time already, but still it's very long, right? Now we're gonna apply the power rule. The power rule tells us that I can bring down the coefficient. I keep the letter x, and I do 10 minus 1 as the new power. And that's it. We're done. So power rule makes life a lot easier. Whenever you have a format that's x raised to a power, any power. What if you have a constant? Oh, wait. The exponent is the coefficient. Yeah, and that's the slope tangents. Exactly, okay? So what we have here is the slope of tangents of the function x to the power of 10 at any point. So if I want to find a slope of tangent at x equals to 1, I put in a 1 into the derivative function, and the slope of tangent when x equals to 1 is going to yield to 10. If x is equal to 2, well, it's going to be a very big number. 2 raised to the power of 9. It's what? 512? 512 times 10, so it's 5,120 would be the slope of the tangent when x equals 2, right? Why? Because the rise is very steep when you have an x to the power of 10. Okay, so this is the derivative function which gives you the slope of tangents at any point. Okay, now what if you have a constant? Now you can think of a constant as 25 times x to the power of 0, right? Remember, x to the power of 0 is actually equal to 1. Now what happens when you have a constant? If you apply power rule on this part, what are you going to get? You're going to get 0 times x to the power of -1, right? I bring down the power as a coefficient, and then I subtract 1. Now, it doesn't matter what this part is. Anything multiplied by 0 is 0. Yeah, so it doesn't matter what the coefficient is or the number in front is. Anytime you have x to the power of 0, which is what you get when you get a constant function, the derivative, it doesn't matter what the a value here or the 25 here, you want to multiply it. Anything multiplied by 0, it's always equal to 0. So we have a rule called constant function rule. Anytime you have a constant function in the format of f at x equal a number, any numerical value, the derivative of the slope tangent is equal to 0. And it makes a lot of sense if you think of it graphically. If you have a constant function, which means the function is horizontal, that's what a constant function means. Well, what is the slope of tangent along that graph, along that line? Well, it's always going to be 0, right? It's flat. Exactly. So the answer for a constant function, it's always equal to 0, right? I'm not going to talk about the other notation, not right now. I'm not going to confuse you with other notation. Just use the prime. That's the derivative or slope tangent. You can do, if you use f at x, then it's f prime at x. If you use letter y, then it's y prime. Okay. So if you have a constant, doesn't matter what the constant is, the derivative is always equal to 0. What if I have a coefficient like 3 times x to the power of 5? Well, the next rule here tells you that anytime you have a constant, all you have to do is carry down the coefficient. And then you do the power rule for x to the power of 5. Well, what happens when you have x to the power of 5 again? You bring down the power, you write the letter x, and you do 5 minus 1. That's 4. So carry the coefficient. Always carry down the coefficient. Anytime you have a coefficient, you just have to copy it down. Take the derivative for the power function and keep the coefficient. Right? Because this is the same thing as 3 times x to the power of 5. 3 is just a constant on the outside. It's a coefficient. So when you take the derivative, finding the derivative of x to the power of 5, whatever answer you get, you just multiply by that same constant again. So the final answer is equal to 15x to the power of 4. So anytime you have a constant or something that's multiplied by the power rule, you just carry that down. Whatever that number is, carry it down. As long as it's constant, a number, not a variable, you carry it down. That's referred to as the constant multiple rule. Now, the name of the rules are not that important. We're not going to ask you, okay, state, the constant function rule or state the constant multiple rule. That's not important. What's important is how to find the derivatives. When you're given a constant, a number, it's always equal to 0. When you have a coefficient multiplied by the power rule, carry down the coefficient, right? That's what's important. What if you have two things add together, like 2x and then 5x to the power of 3? Well, good news is you can find the derivative of each of the two separately, and then you add them. This is referred to as the sum rule. If you have a polynomial function, p at x and q at x, you can simply find the derivative of p and the derivative of q separately, and then add them up together. So you don't have to treat it as like a big, long, complicated question. You can treat each term separately and just do one term at a time. So here, the derivative of 2 times x to the power of 1, because that's really what it is, you carry down the coefficient, which is 2. Now, what happens when you have x to the power of 1, and I want to find the derivative?
It's going to be 1.
Yep, because you bring down the coefficient, the power becomes the coefficient, x to the power of 1 minus 1. 1 minus 1 is 0. 1 times x to the power of 0, or anything raised to the power of 0 is 1. So anytime you have x, it's always 1. So I'm just going to write it down to show you that there's a 1. Okay, here you have 5x to the power of 3. The 5 comes down as a coefficient. And now I need to take the derivative of x to the power of 3. Again, power comes down. Write down x to the power of 2, right? So what you need to remember is going back on the first slide there and focus on all the power rules. X to the power of 0, it's going to be 0, right? It's a 1, so it's going to be 0. X to the power of 1, that's going to be a 1. X power 2, oops, that's not what I meant, not y square. X to the power of 2 is going to be 2x. X to the power of 3 is going to be 3x squared. And so on and so forth, right? This is the power rule. You need to remember the power rule. Constant, 0. Anything that has just x, x is just a 1. X squared is 2x, x cubed, 3x squared, and so on and so forth. So you need to remember the power. And then if there's a coefficient, you just carry the coefficient down. So x becomes a 1, x cubed is 3x squared, carry down the coefficient. Now I need to expand it. 2 plus 15x squared. Okay, it doesn't matter you have more than one term. You can have sum, and then you can have the difference, and they're the same. So if the sum can be different terms, the difference is also can be the two separate terms, p at x, q at x separately, and because you have a subtract, well, you subtract them. So here, again, we're going to be practicing. We've been doing this for a while now. Hopefully it becomes easier and easier every time you do a question. What's the derivative of 3x? 3x, the coefficient is a 3. Yep, good. X is 1, right? We talked about that already. What about the other guy? X to the power of 4. Well, there's no coefficient. Yeah, some of you are finding this really easy, which is good. If you said I'm learning for the very first time, it's okay. It's not hard, right? Just take your time here. Understand what's going on with the power rule. You bring the power down. X, 4 minus 1 is 3. And it's subtracting. So I need to put a minus sign, right? Or think of it as, or you can think of it as a sum. You're adding a -1, right? You get the same answer as well. Right? That's -4x to the power of 3. -4x to the power of 3. You add a -4, same thing as subtraction. So sum and differences are really the same thing here. So the final answer, 3 minus 4x cubed. Right? Now, if I go back to what I did on the first slide here, right? Remember this guy, 5x squared? And we did long, first principles, and we got down to the answer. Now, if you're going to apply power rule, what would the answers be? Y prime, you're going to keep the 5.
10x.
Exactly, right? X squared becomes 2x. 5 times 2x becomes 10x. And you can check. What do we get here? Well, we do get the same answer, right? We do get the same answer. This is a lot longer. This is a lot faster. But we can't use that yet for our first unit test. We do need you to show understanding of the long way. But the good news is, from this point on, after the first unit test, you don't have to use the first principles ever again. We can use the rules. Okay, now let's put them together. Here, so let's try this one. A polynomial function. Okay, so if you are able to do it on your own, great. If you still need a little bit of help, that's okay. It's not that hard. You treat each of the terms separately. Coefficient, you carry down. And then you take the derivative using power rule. Coefficient, you carry down. Power rule. Coefficient, that's not a coefficient because this is a constant. Derivative of constant is 0. So the final answer is 6x plus 2. And that's the derivative function for any point on this graph. If I want to find the slope of the tangent at x equals to 1, then I put in a 1 right there and it becomes 8. Right? So this is called the derivative by applying power rule. Okay, so I'm gonna ask you to try. Right, take a minute. Not a lot of you are using the whiteboard, so I'm not gonna waste the time to share the whiteboard here. You can do it on your own on a piece of paper, right? If you get the answer, you can type it. You can direct message me just so that I know you understand how to do it. Okay. Apply the power rule. Think about what we talked, what we just said, right? Coefficients you carry down. Anytime you have x raised to the power n, you apply the power rule. Keep in mind what a constant will give you and what x to the power 1 is going to give you, right? And you should be able to find this really, really fast. Okay, so I have a couple of you sending me the answers already. Okay, now some of you are missing a couple of the terms, so be careful, okay? So you should have 1, 2, 3, 4, 5. Now, knowing that the last term is a constant, is a 0, your answer should have 4 terms. So this one, you carry down the 5, and then you get 4x cubed. You carry down the -3, you get 3x squared. You carry down the 2, you get 2x. You carry down the -5, and that's a 1, right? X is just a 1. And the coefficient, sorry, the constant is 0. So now, expand and simplify. This is 20x cubed, 9x squared, 4x, and 5, -5. Okay. If you have to do this with the long first principles way, it's going to take you a good 15 minutes because expanding all those terms is going to take a while. But now with the understanding of power rule, you should be able to do this in like less than 10 seconds, right? So this is referred to as the power rule. Now, they also have a couple other names, right? The constant function rule, the constant multiple rule, the sum rule, the difference rule. Well, that's really just adding and subtracting and things like that. Ultimately, I just call this whole thing the power rule. As long as you understand the power rule, which is what I have up here, you should be able to find derivative of all the polynomial functions easily. Now, the next thing is, what if I don't have a polynomial function? What if I have a square root function, right? Do I need to do conjugation? Well, no. As long as you can rewrite this into x to the power of n, you can apply power rule. Well, what's square roots? Can you rewrite square roots of x into a power? Well, we learned that if you have a square root, it's x to the power of 1/2. If you have a cube root, it's x to the power of 1/3. If you have a fourth root, it's x to the power of 1 over 4. So I can actually rewrite a square root into x to the power of n. Now, if you apply the derivative rules, this is going to be a half because you bring down the power. You keep the x and you do n minus 1. Well, what's a half minus 1? A half minus 1 is going to be negative 1 over 2. Now, some people say, well, this looks so weird. Is this actually the right answer? Well, let's do it one more time. Why I'm doing this one more time? Well, because you are writing a unit 1 test and you will get some square root functions. So might as well practice one more time. Limit h approach to 0. F at, actually, let me write out one more step. F at x plus h minus f at x divided by h. So what happens when you have x plus h into the function? Well, that's square root of x plus h. What's f at x? Square root of x. Well, I need to do conjugation. What do I multiply by? I'm going to multiply by a plus b. So this guy is going to be, actually, I'm going to use a different color here. X plus h plus square root of x. X plus h plus square root of x. Now I need to do difference of squares. A squared minus b squared. Take off the square root. Take off the square roots. So a squared minus b squared. That's just x plus h. That's just x. Okay. Now the x and the x will cancel. You're left with the letter h on top. And the h and the h will cancel. Everything is gone. So what's left is 1 over the square root of x plus h plus square root of x. Okay, again, I'm not showing this part, but it's x plus h minus x, which becomes h. And then h and h will cancel out. Okay. Now, what happens when h becomes 0? This guy is 0, which means the answer is 1 over square root of x plus another square root of x. That's 1 over 2 square root of x. Okay. Now, if you compare this answer to what I have up here on the last page with the power rule, are they the same answer? Well, let's see if you guys are good with your native exponents. What does the native exponent mean again? Well, it means this is in the denominator. So this is like 1 over 2 times 1 over x to the power of half. Well, what's x to the power of half again? X to the power of half is the square root of x. So if I combine a half times 1 over square root of x, that's 1 over 2 square root of x. Take a look at that and compare it to what you have down here. Isn't that the same answer? So the power rule works for square root function too. As long as you can rewrite it in this format, you can apply the power rule. So a square root function can be applied, can be the derivative can be found using the power rule as well. Okay, but here's a good practice of conjugation, rationalization of a square root function, right? So anytime you get a square root function, always remind yourself to do conjugation. Multiply by the opposite, x plus b, x minus b. What if you have other fractional exponents? It works the same way as long as you are in the right format. you can apply the power rule. Bring down the power 2/3 x to the power of 2/3 minus 1, right? That's the formula. So this becomes 2/3 x, 2/3 minus 1. 2/3 minus 1 is negative 1/3. Okay. If I want to write it as positive exponents only, this means, oh, I don't know if I need an extra step or does people actually know what this is? This is 1 over x to the power 1/3 or 1 over the cube root of x, right? So this is 1 over the cube root of x. So you can actually put it down in there. That's what it means if it's positive exponents only. So power rule, anything that's in this format can be done using power rule.